Okay, so here we've got a reaction between sulfuric acid and magnesium hydroxide, and we've been asked to calculate the mass of the magnesium sulfate, basically MgSO₄, that's produced from this reaction, right? And we've been told that the mass of magnesium hydroxide which reacts is 41.97 grams. We've also been told that the H₂SO₄ is in excess. So we know that the limiting reagent in this reaction would be the magnesium hydroxide. So we can assume that all of it reacted, and so the amount of what we've been asked about, the magnesium sulfate, the amount produced is really depends on the number of moles of magnesium hydroxide, right? Okay, so how are we going to go about working out that mass that's been asked in the question? Well, for MgSO₄, we can work out the MR from the periodic table. So we can work out the molar mass of MgSO₄ from the periodic table. We've got that mass equals moles, number of moles multiplied by the molar mass, right? So this part we can work out from the periodic table, but the number of moles we cannot work out directly from the periodic table, but where we can work it out from is from the number of we can work this out from the mass if we can convert that to a number of moles, and then use the stoichiometry in this balanced equation. We can use that to work out what the actual the moles of the MgSO₄. So let's go through that process. So let's convert this into an amount of substance in moles. So for MgOH2, I'm going to need to work out as you can see from this, if you want to work out the amount of substance, if we were to rearrange this, we'd get N equals M over Mr, right? So to get the amount of substance, we also need the Mr of MgOH2. So let's work that out. Okay, so magnesium, we've got 24.3. Then, so we've got that, and oxygen, hydrogen, so MgOH2. So that is going to be, so Mr of MgOH, well, I have to put brackets there, right? The Mr of MgOH2 is going to be equal to 24.3 plus 2 times 16 plus 1, right? So this comes from the hydrogen, this comes from the oxygen, this comes from magnesium, and this 2 simply comes from the, the subscript 2, which we've got here, which shows it with the brackets to show we've got 2 OHs, right? So if we work this out, this is going to give us the molar mass of the MgOH2. And in this case, it's going to be 58.3, okay? And that's going to be in the units of grams per mole. Now, one of the things I'm going to actually work on here, beyond okay, so anyway, we've got the molar mass, right? We've got the mass now. So we've got the molar mass, we've got the mass 41.97. If we use the equation which we've got here, which is the N equals M over Mr, we will be able to use that to work out the moles of the MgOH2. So let's do that. So N of MgOH2 is going to be equal to 41.97 divided by 58.3. Okay, so if I bring this just down here to put the equal sign actually here, that is equal to 0.7198971. Okay, now what I'm going to do here is we need to look at the stoichiometry given in the question. For every mole of MgOH2, how many moles of MgSO₄ do we have? So what I'm really looking at is the comparison, the moles of MgOH2 compared to the moles of MgSO₄. Okay. Well, what we can see actually in the question is this is actually going to be a 1-to-1 ratio. We can see this from the balanced equation because there's no, effectively, I mean, the coefficient of both is 1, right? The coefficient here is, there's no coefficient, so it's 1. Here also, there's no coefficient, so it's 1, right? If we were focused on H₂O, it might be different, but in here, we actually just focus on MgSO₄. So, and because of this, we can simply say that therefore the moles of MgSO₄ is actually equal simply to this, right? So 0.7198971 moles. Okay, but now we need to actually take the additional step of working out the mass, right? This is what the question has asked us to do, and we have the equation here for working out the mass. What we need, we've got the moles now, what we need is the molar mass to work out what the mass is, right? So let's work out the molar mass of MgSO₄, right? So MR of MgSO₄ is equal to what? So as you can see from the periodic table, as we kind of highlighted before, magnesium has relative atomic mass of 24.3, which is part of what will form the molar mass here. So that equals to 24.3 plus, and then for sulfur, you can see here, you can see sulfur here, right, and I've separately highlighted it here, right? So for sulfur is going to be 32.1. Okay, and then O4, so that's going to also be plus 16 times 4, right? And if you work that out, what you should find is that the MR overall for this MgSO₄ is going to be 120.4. Okay, so 120.4, and then the units, grams per mole, right? So we now have the moles and we have the molar mass. All we need to do is multiply them. So therefore the mass of MgSO₄ is equal to 120.4 multiplied by 0.7198971. Okay, and what does that give us? Well, that gives us 86.675 6089. Okay, and that's going to be in grams. So if we refer to the question again, what would we find? Well, we find that we've been asked to also, it says give your answer to a maximum Let me use another color, it's a bit easier to see. Give you answer to a maximum of 2 decimal places, right? So, which is obviously we have not got there yet. So if we do some rounding, we will be able to get to the specified answer. So to get it within that specification of 2 decimal places, let's do some rounding here. That's going to be 86.6. There, so we just round it up because we've got 5 there. So that's going to be 0.68. Okay, and that's going to be in grams, so we need our units, and that's going to just say to 2 decimal places. Okay, so in this case, the mass of the requested MgSO₄ is going to be this.